day, viewers. This is 300 Plus Academy, where all we do is exams tutoring, ensuring that you ace your next exams. Okay, still on the subject of mathematics, we looked at percentages, some commercial arithmetic, we've looked at ratio, and we've looked at proportions. Now it's just about time for rate. And when we talk about rate, the first thing that comes to mind is time. Anytime you hear the word rate, you talk about time. Time is involved when you talk about rate. And when we say rate as a topic, it simply means we are comparing a certain quantity as against time. And the best way to understand rate as far as mathematics is concerned, when we talk rate, is to deal in speed, distance, and time. Recall that when you talk speed, speed is distance covered. Speed is the distance covered per unit time. In other words, imagine a body had moved 40 kilometers in 8 hours, then I would say my speed is 5 kilometers per hour. To say 5 kilometers per hour here, to say 5 kilometers per hour here means it takes 1 hour to cover 5 kilometers. That it will, for every 5 kilometers traveled, it is going to take a time of 1 hour. So when we talk about rate, we are usually trying to express quantities as against time. So when we say speed, speed is actually distance over time, and then distance is speed times time, and then time is distance over speed. So with these three formulas, we're going to deal with rate. And when we're dealing in rate, take notes. Be careful when it comes to your units. Be careful when it comes to your units. Your unit must rhyme. And when we talk about rhyming units, imagine that speed is in kilometers per hour. Then you cannot say distance in meters. They do not rhyme. No. You have to change this to kilometers. That is when they can rhyme. So when you talk rate, we are comparing quantities as against time. And one of the things we have to do when dealing with questions involving rate is to make sure that units rhyme and we use our units the right way. So let's get into solving question. A number of questions have been outlined already. Okay, the first question you see on your screen, two questions actually. I'm going to solve one, then you can try out one on your own. And if you have any need for clarity or any further explanation as per the other question, you can just check us out on our website at 300plusacademy.com. Link up with us on WhatsApp and send a DM to the admin. All right, let's get into it. You can see the question. A car travels at 60 kilometers. A car travels 60 kilometers at 30 kilometers per hour. So you're looking at a car that had traveled 60 kilometers. You're looking at a distance of 60 kilometers at a speed of 30 kilometers per hour. Okay, and then a further 180 kilometer, and then a further 180 kilometer at 160 kilometer per hour, and then a further 160 kilometer, and then a further 180 kilometers at 160 kilometers per hour. At 160 kilometers per hour. If I want, I can so use diagrams to represent this. A body had moved 60 kilometers. Let's say this be 60 kilometers. A body had moved 60 kilometers at a speed here. you're looking at a speed of 30 kilometers per hour, and then a further 180 kilometer, but this time at a speed of 160 kilometers per hour. So what do they want in this question? They said calculate the total time taken. Of course, when you talk about the total time, you need to look at the time for this part of the journey. Time equals to distance over speed. The distance is 60 kilometers divided by 30 kilometers per hour. This out. So this is 2 hours. Okay. For this part of the journey, that is going to be 180 kilometers divided by 160 kilometers per hour. That is 1.125 hours. So when you look at it, the first part of the question A, in that question, that's going to be 2 hours plus 1.125 hours. That will be 3.125 hours. That is the total time taken. And then to the B part of the question, it says average speed for the whole journey. You need to understand that average speed is total distance over total time taken. Average speed is total distance over total time taken. So what this means is that the total distance is 60 kilometer plus 180 kilometer, 60 kilometer plus 180 kilometers, all divided by the total time is 3.125. Of course, this will give you 240 kilometers divided by 3.125 hour. So my average speed is 76.8 kilometers per hour. So this looks all cheap, all simple for now. So the B part of the question is something you can get hands on your own. If you have any question, don't forget, check us out on our website 300plusacademy.com, and of course link up with us on WhatsApp there, and of course send your concerns, your issues to the admin, and of course they would attend to you. Okay, as you can see on your screen, they said a swallow flies at a speed of 50 kilometer per hour for 3 hours. So you're looking at a swallow that moved at 50 kilometers per hour for 3 hours. 50 kilometers. In this case, this is speed, and this is time. Okay, and then at a speed of 40 kilometers per hour for a further 2 hours, and then you're looking at another speed of 40 kilometers per hour for another 2 hours. So which means the speed had reduced from 50 to 40, and which means the speed had reduced from 50 to 40. So what do they want in this question? Find the average speed for the whole journey. Average speed is total distance over total time. Total time in this case, you're looking at 3 hours and then 2 hours. So this is 5 hours. Okay, we're looking at the total distance. Of course, we were not given distance, but we're given speed. But we know that distance equals to speed times time. So this is going to be 50 times 3. 50 times 3 for this part of the journey. And that's 150 kilometers. And for this is going to be, the distance here is going to be 40 times 2. That's going to be 80 kilometers. So what you basically have is 150 plus 80. That's the total distance, and that's 230 divided by 5. So that this is 45 6 kilometers per hour. So that is how we, go about calculating our average speed according to that question here. Still very simple at least for now. So moving on, we have another question. As you can see on your screen, it says the airline Concorde flies 2,000 kilometers at a speed of 1,600 kilometers per hour and then returns. Okay, let's say we have an airline Concorde. Okay, it flies 2,000 kilometers. Okay, let this be 2,000 kilometers at a speed of 1,600 kilometers per hour. Okay, that's what the question states. Airline Concorde flies 2,000 kilometers at a speed of 1,600 kilometers per hour and then returns due to bad weather at a speed of 1,000 kilometers. Okay, got here and then decided to return, but this time at a speed of 1,000 kilometers per hour. 1,000 kilometers per hour. Okay. We were told to find the average speed for the whole trip. If you're looking for average speed is usually total distance divided by total time. Now looking at this is to and this is fro, returning. So when we move in this way, travel 2,000 kilometers. So when you look at this, the timing for the to journey, so you're looking at time equals to, this is your speed. Time is distance over speed. Distance in this case is the 2,000. So that's 2,000 divided by 1,600. So that is how I'm going to get my timing. So that this gives me 5/4 hour. Okay. For the fro movement, returning, you're looking at 1,000 kilometers per hour. That is the speed. Of course, it is going to cover the same distance just as it had gone. It's going to return covering 2,000 kilometers. So that your timing here, using distance over time, is going to be 2,000 kilometers divided by 1,000 kilometers per hour. This off. So I have 2 hours here. So that when I talk about my total time, this is 5/4. Time 5/4 is same as 1.25 hours plus 2 hours, 3.25 hours. So that when you look at your average speed, you have traveled 2,000 to and 2,000 through. Your total distance is 2,000 plus 2,000 divided by 3.25. So that is 4,000 divided by 3.25. That is 1230.8 kilometers per hour. That is the average speed, and this is our answer. So look at the question very well, and it's not really difficult talking about rates. Okay, moving on to the next question. As you can see on your screen, a train travels from A to B, a distance 100 kilometers at a speed of 20 kilometers per hour. Okay, and that's exactly what we have here. (20 kilometers per hour), that's the speed, and of course the distance there is 100 kilometers. If it had gone 2.5 times fast, how much earlier? So when you say 2.5 times fast, it means you want to increase the speed, and in this case 2.5 times fast means 20 times 2.5. So it means you want the speed to be 50 kilometers per hour. In this case, that's what the question states. So if I'm looking at this, the timing here, when it was moving at 20 kilometers per hour, time is distance over speed. So this would have been 100 over 20 and this would have been 5 hours. If it had moved at 20 kilometers per hour, it would have arrived after 5 hours at B. But if it had moved 2.5 times fast, it now means that my timing is going to be distance over speed still, and that is going to be 100 divided by 50, and that would have been 2 hours. It would have taken 5 hours if it was moving at a speed of 20 kilometers per hour, and it would have taken 2 hours if it was moving at a speed of 5 kilometers per hour. That's 2.5 times faster. So how much earlier? That's what the question says. That would have been 3 hours earlier. How much earlier? How much earlier? It won't take 5 hours, but now it's going to take 2 hours. So 3 hours. Just subtract this. 3 hours earlier. That is how you get by with questions like this. Okay, moving on. We have another question. As you can see, two men running towards each other at 4 meters per second and 6 meters per second respectively are 1 kilometer apart. You can see, let's say these are the two men running towards each other. Okay, running this way, running this way. They said they are 1 kilometers apart. Okay, two men running towards each other at 4 meters per second and 6 meters per second. 4 meters per second and then 6 meters per second running towards each other. How long will it take before they meet? And this is the case of the rhyming unit I talked about. This is in meter per second, this is in meter per second, this is in kilometer. It does not rhyme. You're mentioning meter here, you're mentioning meter here. It does not rhyme. So I have to convert this to meter. This means 1,000 meters. So the question is, at what time? How long will it take? How long will it take before they meet? Okay, this is quite easy. Let's assume that they meet at this point. Now let the distance from here 0 to 1,000 here. Let the distance from here to here be x. From here to here where they meet, this is their meeting point. Let this be x, so that the distance covered here is x. The distance covered here is 1,000 minus x. So the point here is this: the timing it will take for this to move from here to here, and the timing it will take for this to move from here to here is basically the same. So let this be A, let this be B. Timing it will take A to move from here to here, and the timing it will take B to move from here to here is going to be equal. Though they are moving at different speed, but the timing it will take, because they started moving at the same time, the timing will be the same. So how do we calculate time? Time is distance divided by speed. Distance here is x divided by what? 4. And then the timing here for B moving in this direction, the timing, the distance here is 1,000 minus x divided by 6, because of course the speed here is 6. So this is the equation we are going to solve. And most times as you proceed under rates, you're going to be having questions that has to do with you forming equations. So this becomes 6x, 4 moves here, becomes 4 into bracket 1,000 minus x. 6x equals to 4,000 minus x, minus 4 times 1,000, 4,000, 4 times x, 4x. So when this moves here, 6x minus plus 4x equals to 4,000. So that 10x equals to 4,000. So that x equals to 4,000 divided by 10. X equals to 400 meters. So it means from here to here, x, that is 400, and from here to here, so we have 400, and then we have 600. But the question is this: after what time? How long will it take before they meet? How long it will take before they meet? This is moving at 4 meters per second and I traveled 4 meters per second. So timing here is actually distance over speed. So this is what? 400 divided by 4, that is 100 seconds, because this is in meters and this is in meter per second. This of 100 seconds. If I decide to use this, the timing here is going to be 600. That's the distance divided by the speed. The speed is 6 meters per second. So this will still give me 100 seconds. So they basically meet after 100 seconds or 1 minute 40 seconds. So that is the answer there. A running towards B. The timing they meet is going to be the same, and that is how you go about that question. So that ends that question. Okay, moving on, we have another question. It says a car traveling at 90 kilometers per hour is 500 meters behind another car traveling at 70 kilometers per hour in the same direction. How long will it take the first car to catch the second? A car traveling, okay, let this be the first car. It is traveling at let this be the first car traveling at 90 kilometers per hour. 90 kilometers per hour is 500 meters behind. Okay, let this be another car. So the distance from here to here is 500 meters. This is car A, this is car B. A, car B. This is 500 meters behind another car. You can see from the question, another car traveling at 70 kilometers per hour. So which means this is traveling at 70 kilometers per hour. And then they asked, how long will it take the first car to catch the second? Okay, after some time, definitely B would have moved this way. This will be B. But at the same time, this moving, it gets to a point where A just catches up with B. So that's just that about that. So invariably, this B would have moved additional X from here to here. That's X kilometers. And then this car A will need to cover 500 meters and then cover the X kilometers before it catches up with car B. So that is the thinking behind it. But take note, this 500 meter is there to get you confused, because when you look at it, this is in kilometer per hour, this is in kilometer per hour, this is not rhyming. So you have to convert this. This means 0.5 kilometers. You divide 500 by 1000. So it means that car A is 0.5 kilometers behind car B, and it is moving at 90 kilometers per hour, but there is a car in front moving at 70 kilometers per hour. After a given time, car B would have moved X. So for car A to catch up with B, car A must have moved, covered the 500 meters or 0.5 kilometers and covered the X. That is when they meet. So from this, we are going to form equation. But take note, the timing it will take A to move from where it is to the point where they meet is equal to the timing it will take B to also move. That is what links them. So when you have questions like this, you have to look at what links them. It just simply means this is here, this is here. They start moving at the same time. After a given time, then they meet. So it means the timing for A to move from here to here and the timing it takes B to move from here to here is the same. So when we talk about timing for A, time is actually distance over speed. The distance that A will cover is 0.5 plus X. That's the distance, 0.5 plus X divided by the speed, 90. And then the timing for B is going to be X divided by 70. Solving this equation, we'll be able to get X, talking about the distance covered first. So what this means is 70 moves here, 70 into bracket 0.5 plus X equals to 90X. So that 70 times 0.5, 35 plus 70X equals to 90X. So that what this means is 35 equals to 90X minus 70X. That's 20X equals to 35 equals to 20X. So x will be 35 over 20. 35 over 20, that's going to mean 7 over 4 kilometers. That's what that means. I don't want to put this in decimals yet. So that is what that means. The units just sort of, right? Now that I have my x, what the question is asking is how long will it take the first car? So I can calculate my timing because my x is now 7 over 4. Okay, if I consider the movement of car A, I'll be saying, okay, time is distance over speed. The distance here for car A is 0.5 plus 35 over 20. 7 over 4 here means 1.75 kilometers. So 0.5 plus 1.75 kilometers, okay, divided by the speed is 90. So this is going to be 2.25 over 90. That's kilometers divided by kilometers per hour. So kilometer cancels kilometer. That is 0.025 hours. That will be 0.025 times 60 times 60. That's first to minutes and then to seconds. So 90 seconds. That is what it will take for car A to catch up with car B. That's if I'm looking at things from the perspective of car A. If I'm moving from the perspective of car B, I'll be saying timing for B is actually the distance covered over the speed. So when you look at it, the distance here is just the x, and that is 1.75 kilometers divided by the speed here is 70 kilometers per hour. So this of 1.75 divided by 70 is still going to give you 0.025 hours, which invariably will now mean 90 seconds if you convert. So you can see that it is the same, either you're using A or you're using B. The important thing is you have to construct your equation and then you have to look for that variable. You have to look, is it the distance, is it the speed or the time that links car A and car B? In this case, it is the time, and that is what links them here. This is where you get the job done as far as rate is concerned. So the answer here is 90 seconds. Look at the question very well again. So that ends that question. Okay, we move on to the next question. How long is a train which passes a signal in 20 seconds? How long is a train which passes a signal? Okay, let this be my train. How long is a train? Okay. Let this be my signal. How long is a train? Let this be my signal. So I needed the train to, pass. I needed the train to pass. So the question says, how long is a train which passes a signal in 20 seconds? Okay, so it's going to take 20 seconds for this train to pass this way. So the timing is 20 seconds. But I was told that this train is moving at the speed of 108 kilometers per hour. This train is moving at the speed of 108 kilometers per hour. How long is the train? That is the question. So the train is basically moving its own distance. So when we try to look at the length of the 20 seconds here, you see this is 108 kilometers per hour. So they're asking me how long, what is the length of this train? What is the length of this train? Asking me the length of this train is like asking me for distance. It's like asking me for distance. So the unit does not rhyme. This is in kilometer per hour. This is in seconds. So I'd rather that I convert this to to hour. So if I'm converting this to hour, this is going to be 20 divided by 60 and then divided by 60 again. Recall that seconds, minutes, and then hour. 60 seconds make 1 minute, 60 minutes make 1 hour. When you're moving this way, you're going to divide. So this is going to be my timing. So I'm going to see the distance of the train. That's for the train to move from here this way to pass the signal. This is my signal, so that the train just moves. So the train is moving its own distance, but moving at the speed of 108 kilometers per hour. It was able to pass through that signal in 20 seconds. So how long is the train? So distance actually is speed times time. So when I look at this, the speed here is 108 kilometers per hour times the timing. This is in hours now. That is 108 kilometers per hour times 20 over 60 times 60 hours. So when I look at this, hour cancels hour, this out. So I have 108 times 2 divided by 60 times 6. So 6 here 1, 6 here is 118. So this is 36 over 60. 6 here will give us 6, 6 here 10. So this is 0.6 kilometers. That is the length of the train. 0.6 kilometers or 600 meters. If you multiply by 1000, that is the length of the train to move from here to here, so that it has moved completely past the signal. So that ends that question. Moving on to the next question. A train of length 108 meters approaches a tunnel of length 620 meters. Okay, I'll say let this be my tunnel. Let this be my tunnel. Okay, let this be my tunnel. Now, I like to use diagram when I deal with word problems, because it just makes the work very crystal clear. So a train of length 180 meters approaches. Okay, let this be my train. This is my train, and my train here is 180 meters. 180 meters. That's the length of my train. 180 meters approaches a tunnel of length 620 meters. Okay, this tunnel is 620 meters. That's what the question says. How long will it take the train to pass completely through the tunnel? So we want a situation whereby the train passes completely through the tunnel. Now this is the train. So for the train, you're first of all going to move 620. For the train, this is what you move, 620, and then you move your own length, which is 180 meters. So that cumulatively, this means 620 plus 180, this means 800 meters. That's it. But also in the question, we were told that the train was moving at a speed of 54 kilometers per hour. So when you say 54 kilometers and 800 meters, they do not rhyme. So you must make sure that this rhymes. So this means 800 divided by 1000. This means 0.8 kilometers. So when you look at what they want in the question says, how long will it take? So the timing it will take. Timing is actually distance over a speed. The distance here is 0.8 kilometers divided by 54 kilometers. That is distance, 54 kilometers per hour. Kilometers cancels kilometers. 0.8 divided by 54. So this will give you 0.0148 hours. If I'm to convert this to seconds, that would be times 3600. This is 53 0.33 seconds. So that is how long it will take the train to pass through the tunnel. Look at the question very well. So it is word problems, and I recall while I was teaching you about word problems on fractions, I said when you are dealing with word problems, you can use diagrams so that things are a lot more clearer. So that ends that question. We move to the next question. It says an earthworm of length 15 centimeter is crawling along at 2 centimeters per second. So we basically have, let this be my earthworm. I've decided to use drawings all through this solving. An earthworm of length 15 centimeters, so which means the length of my earthworm is 15 centimeters. Okay, is crawling at 2 centimeters per second. So the earthworm is crawling at 2 centimeters per second. Okay, an ant overtakes the worm in 5 seconds. So we basically have an ant. Let this be an ant. Let this be our ant. Okay, the question says an ant overtakes the worm in 5 seconds. So this is the ant. So after 5 seconds, for example, let this be the earthworm here. Let this be our earthworm, and the ant in this case will need to first of all cover for the 15 centimeters, and then the earthworm in 5 seconds must have moved, let's say, x centimeters. In this case, must have moved another x centimeters. So for the ant to overtake, for the ant to now be here, for the ant to be here, the ant must, it's just about to overtake the earthworm. For the ant to be here, the ant will have to move 15 centimeters and x centimeters. Look at it very well. For the earthworm is just 15 centimeters. The ant is here. So for the, after 5 seconds, the earthworm must have moved x centimeter. So for the ant that is at the back here to overtake, you can see in the question, an ant overtakes the worm in 5 seconds. How fast is the ant walking? So what we want to get about the ant is the speed with which the ant is moving to be able to overtake the earthworm after 5 seconds. So in this situation, you look at what connects the two, and in this case that is looking more like our x, but that's not the issue. 5 seconds, 5 seconds. Okay, so this is it. When we talk distance is actually speed. Distance is actually speed times time. Okay, so looking at this, I'll say for the ant, the distance here now is 15 plus x. The timing here is 5 seconds. That's talking about the ant. So I'll be thinking, for me to get the speed will be distance over time, and this will mean 15 plus x divided by 5. 15 centimeter plus x centimeter divided by 5. But I don't have my x, so I'm going to use the earthworm to calculate my x. So what that means here is I'm not going to be bothered about the 15 centimeter length of the earthworm here. I'm concerned about the x centimeter move at a speed of 2 centimeters per second in 5 seconds. So in this case, so for the earthworm here, distance is actually speed times time. Yes, distance is speed times time. So in this case, the speed is 2 centimeters per second times 2 centimeters per second times the timing. The timing is 5 seconds. Seconds we take out seconds, that's going to give us 10 centimeters. So our x here which is the distance, is 10 centimeters. So when I come here, that's going to mean 15 plus 10 over 5, that is 25 over 5, so that the speed is going to be 5 centimeters per second. That is the speed with which the ant must move in order to be able to overtake the earthworm. Look at the question very well again. There is nothing really too difficult. So the question is, how fast is the ant walking? The ant is walking at the speed of 5 centimeters per second. So that ends that question. Moving on to the next question, it says a train of length 100 meters. Let this be my train of length 100 meters is moving at a speed of 50 kilometers per hour. So it means my train is moving at 50 kilometers per hour. Okay. A horse is running alongside the train. So it basically means we have, let this be our horse here. We have a horse moving alongside the train. We have a horse moving alongside the train at a speed of 56 kilometers per at a speed of 56 kilometers per hour. How long will it take the horse to overtake the train? So after a given time, distances must have been moved. Okay, let this be the train now. Let this be the train. And of course, let this be the horse just about to overtake the train. So you look at what the question is saying. The horse is moving at 56 kilometers per hour. How long will it take the horse to overtake the train? How long? We're looking at time. So when you look at this, let the distance from here to here, let this distance be x. Let the distance be x kilometers. And when you're looking at the horse in this case must first of all cover the 100 meter, which is the length of the train, and then cover the x kilometer here. Now you look at something, certain units are not rhyming, and that is what you should keep an eye on. This is 100 meter, it is not rhyming, so I have to convert it. This is in kilometer per hour. I have made the x to be in kilometers, so you need to keep an eye on those units that are not rhyming with the other. So 100 meter to kilometer, that's 100 divided by 1000, that is 0.1 kilometers. So this means 0.1 kilometers. In the case of the train, it will basically move the x kilometer. In the case of the horse, it will have to move the length of the train, 0.1 kilometer, plus the x kilometer newly covered by the train. So that what we have is that the timing it will take the train to move this x kilometer is the same timing it will take the horse to move 0.1 kilometer plus x kilometer. So the timing for the horse equals the timing for the train, and we all know that time equals to distance over speed. So in the case of this, the distance is 0.1 plus x over our speed is 56. For this, the timing for the train is going to be the distance x divided by the speed, which is 50 kilometers per hour. So we're going to solve this that way. We'll be able to get our x. Okay, 50 comes here, 50 into bracket 0.1 plus x equals to 56x. So 50 times 0.1, that is 5 plus 50x equals to 56x. So what that means is 5 equals to 56x minus 50x. So 5 equals to 6x. Therefore, x equals to 5 over 6 kilometers. X is 5 over 6 kilometers. So with that, in the question we were asked, how long will it take the horse to overtake the train? So with this, we can now calculate for our timing. This is timing for the train. Timing for the train, talking about the train, timing for the train is x over 50. X is, the time is going to be 5 over 6. In this case, the 5 over 6 is the distance divided by the speed, which is 50. So this will mean 5 over 6 times 1 over 50, year 1, year 10. So this is 1 over 60 hours. To say 1 over 60 hours, if you multiply by 60, that will give you 1 minute. So it will take us 1 over 60 hours or 1 minute for the horse to catch up with the train. If you decide to use the timing for the horse, the timing for the horse in this case is 0.1 plus x. Okay, this is if you consider the timing for the horse. This is 0.1. 0.1 means 1 over 10 plus 5. X is 5 over 6. 5 over 6 divided by 56. LCM of 10 and 6, that is LCM of 10 and 6, that is 30. 10 in 33, 3 times 1, 3. 6 in 35, 5 times 5, 25. All divided by 56. Of course, this is going to mean 28 over 30 times 1 over 56. 28 in 1, 28 in 56, 2. 28 here to 1, 28 in 56, 2. So this means 1 over 60 hours, which is the same thing. So the answer is 1 over 60 hour or 1 minute and will be correct. That is the time it will take for the horse to catch up or overtake the train.